You might have heard that integration is difficult, but it's really not so. If you learn the right technique, you will find that even something as scary as this can be extremely easy. For example, I look at this question and I will say, okay, this is x cube, so that means there must be a by 4, and then that goes inside, it becomes x power 4, then there is a cos which will become a sine, and so on, and then I will write 2 plus 5 sine x power 4 whole to the power of 10 divided by 4 into 5 into 10. This is the answer to this question. Let us learn how you can do this. So now when we want to understand how to do an integration question, basically let us first understand what is integration all about. Integration is the reverse process of differentiation. For example, if I wrote d sine x by dx, what will I get? I'll get cos x. Now I don't write the by dx, so if I just leave the d sine x, I'm going to get cos x dx. This is called the differential of sine x. Really, integration is the reverse of differential, because you do differential and you put an integral symbol on top, you will find that it cancels out. So when I put an integral of a differential of sine x, these two fellows just cancel out, giving us sine x as the answer. Of course, I have put an integral symbol here, so I'll put an integral symbol there. So what have I done? I have done integral cos x dx. I wrote it as d sine x, integral of d sine x. When the integral and d come next to each other, they destroy each other. So think of it that way, very simple. Integral and d must be next to each other. You can't, of course, cheat by just bringing the dx here and keeping the cos x on that side. So what you do is, you push everything inside the d. So I like to think of it as a process where you're saying cos x dx is d of sine x. You're taking cos x and pushing it inside the d. When you push it inside the d, it becomes d of sine x. Right? Let us think about another example. So for example, if I have 1 by x dx, d of what will give me 1 by x? D of log x will give me 1 by x. So d of log x would have been 1 by x dx, because actually d by dx of log x is 1 by x. So d of log x is 1 by x into dx. So 1 by x dx, you can take the 1 by x and push it inside the d, it becomes log x. When it goes in, it becomes log x. Okay, I'll keep using this language. You will find that learning this language makes it very useful. We'll say push things inside the d. So take this fellow and push it inside the d. When you're differentiating, you're pulling things out of the d. When you're integrating, you're pushing things inside the d. So think of it as an idea. Okay. Now let us take another example. X cube dx. Now I don't know anything which has x cube dx. X cube comes out. But you know that if you had taken x power 4 and I had done a d of x power 4, let us think about what will happen. So I'm going to write that here. D of x power 4. What would that have given me? It would have given me 4x cube. But I don't have a 4. So I will put a 4 here and then I will divide by a 4. Now I've got a 4x cube dx. Let us take the 4x cube and push it inside the d. You will get d of x power 4. But then what to do with this 1 by 4? Nothing. Just leave it outside. So it is 1 by 4 d of x power 4. Is that clear? This is the way we will take something and push it in. So for example, x power n dx, you can write this as d of x power n plus 1. Because what will d of x power n plus 1 give me? N plus 1 x power n dx. But then I don't have an n plus 1. So I must multiply and divide by n plus 1. Right? So I'll multiply and divide by n plus 1. This whole thing went inside like that, but then this is left over, so therefore n plus 1. So what was this? X power n dx is d of x power n plus 1 by n plus 1. Okay. Now you know d of root x is 1 by 2 root x dx. So if I want to push 1 by root x inside the d, what do you think I should do? I should multiply and divide by 2. The 2 here will remain as it is. This 1 by 2 root x will go in, become d of root x. but that 2 will remain, right? So that will continue coming in here. So I'm going to use this when we are solving problems. I'm going to say that let's take this 1 by root x and push it inside the D. You must understand that to do that, I must multiply by 2 in the numerator and denominator, push this inside. Okay, so let us take this and then move on to the next step, because the next step will be to do an integral. So for example, if I wanted to get integral dx by root x, my goal is to first push everything inside the D, so there is nothing else remaining. It is just integral d something. The integral and d will cancel. Okay, let us see how to do that. So what I'm going to do is I'm going to multiply by a 2 and multiply the numerator by a 2. Constants can go in and out of the integral and in and out of the d. So there is no problem. What about 1 by 2 root x? Dx by 2 root x goes inside as d of root x. The 2 of course remains as it is. So therefore this is equal to that. But now aren't the integral and d next to each other? They are. So we can just simply cancel them out. The answer is 2 root x. So integral dx by root x, the answer is 2 root x. Okay. Now this was very simple. Let us then use this as an idea to solve a bunch of questions, so that will give us a little bit clarity on exactly how to go forward. Now let us look at what we learnt a little bit more carefully. So for example, if I have x power 7 dx, I want to integrate x power 7 dx, I can't take x power 7 inside the d directly, because if it goes, it should become x power 8. But what will be x power 8 when you do a differential? It will be 8x power 7. So I should have an 8 here. So I will put the 8 and then I will divide by 8. So let us write the question again here. I've got x power 7 dx. I transformed it by multiplying by 8 and dividing by 8. Now if this fellow goes in, don't think it is going to go in as 8x power 7. It will transform and go inside the d. What will it transform as? It will transform as x power 8. So 8x power 7 dx is d of x power 8. The by 8 is of course always there. Okay, so can you see that this is equal to d of x power 8? Quickly check. Always after you do this step, you can check. D of x power 8, what is that? 8x power 7 dx. So when it went inside the d, it became d of x power 8. Now you know that integral dx power 8, this 1 by 8 can be bought out. So therefore the answer is x power 8 by 8. So that's clear? Now let us take this second question, which is secant square x dx. Now you already know that d of what will give me secant square? D of tan x is secant square x dx. And therefore integral secant square x dx is the same as integral d tan x. Because when I take the secant square and push it inside, secant square goes inside the d, it becomes different, it becomes tan x. Now what is left? Integral d cancelled out. And so what do we have? Integral secant square x dx is tan x. Now please keep in mind that, in fact this is the most important idea. Keep in mind that this is x and that is x. This form is secant square of something, a blob. D blob, same blob. Now instead of x, suppose I had a y. What will I get? Secant square y dy. This and that must be the same. So secant square y dy, the answer is tan y. Of course, in each of these cases, I must add a constant c, which I am not doing. Let us first learn this step. You always know that you must add a constant, right? Integration constant, which I am not going to do. So is that clear? Secant square y dy is tan y. What will be secant square root x d root x? This is also root x, that's also do root x, okay? By the way, if the question was secant square root x dx, this is a very, very different question. I am talking about secant square root x d root x, secant square x dx, secant square y dy, secant square blob d blob, secant square root x d root x. What is the answer? This will be tan root x. Okay, so the answer to this one is tan of root x. Okay, now let us take something like this. Secant square blob d It has to be the same blob, same thing. Then the answer is tan of root of 2 plus 3x. It is tan of this quantity. You don't have to think about this is secant square of what. Secant square of something, d of the same thing. Answer is tan of the same thing. That is important. Okay. This step is a very important step. This is called the invariance of integration formulas. So for example, if I have secant square root x d root x, the fact that I have a root x here, the root x doesn't really matter. Whatever came here, the answer that was there earlier, for this the answer was tan x. Instead of x I have replaced by root x, but I replaced it not just here, I also replaced it there. So when I replace it in both places, the answer becomes tan of root x. So that is very critical. We will use this a lot because what we are going to do is the reverse chain rule method, where we will push things step by step. Remember that whatever you are seeing here and whatever you are seeing there, if they are the same, then in terms of this we look at the rest of the function. So I will look at this as secant square of the stuff inside. I don't think of it as secant square of the root of etc. etc. I will think of it as secant square of the blob. Okay, so secant square blob d blob, answer is tan blob. What is blob? Whatever, as long as these two are the same. Okay, let us try this out with a few examples. We will apply this in sequence, one after the other. Let us now apply what we have learnt to this question. Okay, now if you see, this is secant square root x. Unfortunately, I don't have d root x. I have dx. But I also have a 1 by root x here. So my first job is to push this inside. I will push this piece by piece. Okay, so let us take this 2 and then multiply by a 2. Why did I multiply by a 2 denominator? Because I know 1 by 2 root x dx. 1 by 2 root x goes inside as d root x. So this basically becomes 2 times integral secant square root x. Till here I have not done any changes. Now this 2 root x, 1 by 2 root x goes inside the d as d of root x. Hey, now I have got root x, right? Secant square root x d root x. Secant square x dx, what was that? Tan x. Secant square y dy, tan y. Secant square root x d root x, tan root x. And then of course the 2 remains. And so this is the answer to the original question. So what are we doing here? We are taking piece by piece and pushing inside the d. Then relative to this item, we look at what is outside. The absolute function does not matter. The relative function matters. Okay, so I could have looked at that here, but you see here it is root x and that is x. I don't know what to do there. But if I looked at this and pushed it inside, then relative to this, this is very easy because it's just secant square root x. It will take a little while to get used to this idea, but please do invest time in learning this, because once you have learned this, you will find most of integration becomes extremely simple. Let us now look at this question. So if you see this, I can't look at this cos e power x because this is x, that is e power x, and so on, right? So is there something that I can push inside? That is the key question. You can push the e power x inside. E power x dx is d of e power x. So the next step will be cos e power x d e power x. I just push the e power x inside. Now you see the rest of it I did not even change. Now cos x dx was sin x, d sin x. And then of course the integral will cancel out. Cos of e power x d e power x. Cos y dy sin y. So this is going to give me integral d sin of e power x, and I can cancel that out. Do you see that cos of x dx will be d sin x. Cos of y dy is cos of y dy d sin y. Cos of e power x d e power x d sin e power x. Integral d next to each other cancels. I hope the idea is clear. I am just pushing things one by one. Let us take this fellow. Now if I take this one, I can't push cos x square because this is x. This is also x square. Can't do anything. Let us take x and try and push it inside. Now you know that 2x dx is d of x square. I need to have a 2 because d of x square will be 2x dx. How do I get a 2? So let's take this question as I. If I put a 2 here, I need a 2, so I put a 2. 1 by 2. Notice I have not changed anything. I put a 2 there and I divided by 2. Okay, 2x goes inside the d, becomes d of x square. So let me write that here. The half is still there as it is. So this is cos of x square dx square sine of x square in the denominator. Now can you see this is x square, this is x square. Cos x dx, d sine x. Cos y dy, d sine y. Cos x square dx square, d sine x square. So let's write that half as before, the integral symbol as before. Cos x square dx square is d of sine x square divided by sine x square, because this was already there. Now think of it like this, dy by y, right? So this is dy by y. Dx by x, 1 by x dx, what is that? D of log x. Dy by y, d of log y. D of sine x square by sine x square, d of log sine x square. So this is going to give me d of log. So now you know that d of log, the d and the integral cancel out. So I'll write the half, the integral d got cancelled out. So I have log of sine of x square. So I hope that is clear. I should have technically written an integral and a d, and I just simply removed the 2 because this would have become half integral d of log of sine x square. Why did that happen? Because this was d blob by blob. dx by x, d log x. dy by y, d log y. d sine x square by sine x square, d log sine x square. These two fellows cancel out, so this is our answer. So I hope that part is clear. Now the important thing to keep in mind is that we are taking things and putting them inside the d, one by one. And relative to the stuff inside the d, you are observing the rest of the world outside. So you are observing the outside integrand in terms of the relative nature, in terms of the stuff inside the d. And as you take things and push them one by one, what is inside the d is also changing. Ultimately, everything goes inside the d, like in this case, there is nothing left. Then the integral and d will cancel out. So this is the essence of integration. By the way, this is exactly the reverse of chain rule. That's why we call this reverse chain rule. Like for example, something like this. Let's say we want this part, d of sine x square. So I'll write d of sine x square. Now if I wanted to differentiate chain rule, what would have happened? Sine comes out as cos x square. You will still be left with d x square. And then dx square, the x square has to come out, it would have become 2x. So you would have ended up writing it like this, 2x cos x square dx. Now notice that's exactly what I did in reverse. So first I took the 2x and pushed it inside. We pulled that out last, now we are pushing that in first. It becomes d of x square. Cos x square remains as it is. Then cos x square dx square, cos x square goes inside, becomes d of sine x square. And of course, if I had a by sine x square like in this case, that will also go in and become d of log sine x square. So I hope the basic idea is clear to you. Okay, let us do a couple of more questions because that will make this clear. You must practice at least 100 questions like this, then you will find that you will become super fast in integration. Let us now look at this question. So here we have integral 2x plus 7 power 8, right? Let me write it properly, 2x plus 7 to the power of 8 d of what? Now I have got a d of x. I want a d of 2x plus 7. Okay, so how do I get a 2x plus 7? I'll just simply put a 2x. But wait a minute, I can't just simply put a 2 there, right? I must divide by 2. But 2 is a constant, it can come out of the integral. So I will pull it out and write it here. So d of 2x is the same as 2 times d of x. So the 2 and this 2 will cancel out. So you can see that d of 2x, so we've got 2x. But we don't yet have this 7. But you can always add a 7. Why? Because d of a constant you know is 0. So d of 2x plus 7 is the same as d of 2x, which is the same as 2 times dx. And that 2 and this 2 cancels out. Okay. Now I have got blob power 8 d blob. Now if you remember the formula, t power 8 or x power n formula, x power n plus 1 by n plus 1, we can directly write this, or I can multiply and divide by 9 And then I've got 9t power 8. Either way, you know that you can write 2x plus 7 to the power of 9 by 9. That would be the answer for this part. There is already a 1 by 2. So 2 into 9. So this gives me 18. So 2x plus 7 power 9 by 18. I hope that is clear. Now, if you remember the formula, you can say that this is t power 8 dt. Okay. Or you could have just simply put a 9 here and a by 9. Now this 9 blob power 8 d blob, this goes inside as d of 2x plus 7 power 9. And then the d and this will cancel out. That's what I get here. The 9 and 2 are basically hanging around here. So I hope this is clear. Let us take the next level question and see where we need to apply slightly more complex ideas, but also include this kind of thing where we have 2x plus 7 there. So now let us look at this question. So if you see this question, I'm going to say x cube has to go inside first. Then it will become x power 4. Then cos x power 4 goes inside, will become d of sin x power 4. There is a 7, so I'll divide by a 7. You can do this mentally, okay? But what I'm going to do is I'll write it as steps. Then we will look at what we can do next time. Next question, we'll try and do it mentally. So first, I'm going to put a 4. Why? So that it will go in as cos x power 4. Because I need x power 4 inside the d, so that I can go take the cos x power 4 next. But I can't just randomly put a 4, right? I must also divide by the 4. Now this goes inside. Once it goes inside, it becomes d of x power 4. Then cos x power 4 dx power 4 will become d of sin x power 4. Can you see that? So we are skipping a few steps. Don't do that for your school exams, but it's good to learn it this way. So 1 by 4. This has already gone in. That has also gone in. Two things have gone in. What is outside? 3 plus 7 sin x power 4 to the power of 5. But you see, I need this. If I want to think of this as blob power 5, I need blob here. I need 7 sin x power 4 plus 3. So let us put a 7. But that means I must divide by a 7. That 7 comes all the way out, so it becomes 4 into 7. Right? Now I need to add 3. But adding 3, there is no problem. Why? Because 3 is a constant. So you can always add a 3. I can add it on this side or that side, really doesn't matter. So I've got blob power 5. You know blob power 5 d blob? What is that? Blob power 6 by 6. X power n plus 1 by n plus 1. Okay. Or you can multiply by 6, divide by 6, etc. We will assume you know that. So 1 by 4 into 7 into 6. 3 plus 7 sin x power 4 whole to the power of 6. So I hope this is clear, right? Now what we will do is that we will try to do the next few questions mentally where we can write the answer directly. You must practice doing this mentally a few times. You will find that in the beginning it looks hard. Just a little bit of practice, half an hour of practicing, you will find you will be able to do everything yourself. Now let us look at how we can solve each of these questions mentally. Follow my argument very, very carefully, okay? So first what I will do is I will look at this question. First thing that can go inside is x. So but I need a 2. I'm going to put a 1 by 2. 2x goes inside, becomes d of x square. So now this is inside d of x square. E power x square also goes inside d of e power x square. Now I need a 3. So I will multiply and divide by a 3. So I'll multiply by 3, divide by 3. So I'm going to get 1 by 2 times 3, which is 1 by 6. Okay. Now I've got 3 e power x square plus 5. So that is d of, just imagine, this whole thing has gone in and it's become d of 3 e power x square plus 5 by 3 e power x square plus 5. So it is ln of or log of 3 e power x square plus 5 by 6. So that is the answer to this question, of course, plus a constant c. So I hope that is clear. Now let us take this one. Now first thing I need to push is root x. Okay, 1 by 2 root x would have been nice because that will take me inside as d of root x. So I'll multiply and divide by 2. So 1 by 2 root x goes inside, becomes d of root x. This is gone. This has become d root x. Cos root x, d root x, d sin root x. E power sin root x, d sin root x, e power sin root x. But there's already a 2 outside, so that means 2. Okay, you will need a little practice with some of these. Try them out, write steps if you want, but then you should be able to do it mentally. Okay, so let us come to the last one. Okay, so if I take this is dx by x log log x. So first let's push the x inside. What do I get? D log x by log x log x. Don't worry about that one. D log x by log x. D blob by blob. What is that? That's going to be d of log blob. But what is inside is already log. So this is going to become d of log x. Then this is also gone in. And now what you have there is d log x by log x. So that means log x. So that is the answer. Log of x. Now I know this might have been a little fast, but you do need to practice at least 50 to 100 questions just with this reverse chain rule idea. The more you practice, the faster you become. So definitely look at mental practice for problems of this kind.